One is oscillating like this, one tube, and when there is no flow, others will also oscillate same way. Okay. But when there is a flow, then one tube will oscillate more, other will less, because if it is a first, it has a more oscillation. Then what will happen? I will just change the color. There will be that white one will be like this. So there is a difference between the white and green. This is a phase difference phi. That phi is proportional to m. M is nothing, it is the mass. Now another concept is very important. People will ask you, or if not ask, but as an engineer should know. What is density? What is density? Density is equal to mass upon volume. Volume means kg per volume, na? So you can convert that mass to the volume by knowing the density. So the benefit of the mass flow meter is that it is directly measuring the mass, means it is directly measuring the density, means the identification of the fluid is also it can give you. Now after mass there is a what flow meter? It is EMF, electromagnetic flow meter, right? In the electromagnetic flow meter, the important thing is conductive fluids. If fluid is not conductive, then you cannot use electromagnetic flow meter. You can use electromagnetic flow meter only on the application where fluid is conductive. And I see in a many interview of the instrumentation candidates, this question is compulsory. Everyone asks these questions. Conductive. Then they ask electromagnetic flow meter, what is the principle? Principle is Faraday's law. Faraday's law. What is Faraday's law? So if I talk about in context with the flow meter, electromagnetic flow meter, so it is work like this. Electromagnetic flow meter is nothing, it is an expensive piece of pipe. Okay, so if you see here, it will look like this. This is a pipe. If you see, this is a pipe. This is a pipe. But you see from this side, it will look like this, like this. So electromagnetic flow meter, it has two electrodes. And what Faraday's law says? In a conductive flow meter, when it have a movement in a magnetic field, electromagnetic force generated, EMF generated. So we have to create electromagnetic field. So how electromagnetic field will generate? By the coil. Again, this is the basics of engineering. If I want to generate electromagnetic flow meters, then we will have a coil. In that coil, if we pass through a known current, a known magnetic field will develop. Okay, so what we will do? We will put two coils. In electromagnetic flow meters, normally we put two coils. Okay. Okay. Fine. Okay. Now you see there's a wires. One wire is for this. One wire is for this. One wire is for this. And one wire is for this. Okay, all wires will come out. This is a coil. So we will have one coil housing so that it is protected from the environment. You know, coil na तार को लेकर लपेट तो coil बन गई. So it should be protected from the environment. So we will have a coil housing, and on the top of it I have a junction box, and it has a two glands. This is a flow meter head. Okay. Now what's happening inside this? Now I have a coils. When I give a current to the coil, a known magnetic field will generate it. And there's a water or any fluid is moving inside this. I have given, now this is the coil, this is the electrode. In the coil I have given the known current, so that a known magnetic field will generate. Okay, these are the two electrodes. They will measure whatever EMF will generate. Then I will send it up. Okay, now this distance we know it is a L, distance between the two electrodes. So this is L, and this flow is happening with the velocity v. So as per Faraday's law, E is proportional to B, E is proportional to V, V is the velocity of the fluid, and E is proportional to L. And we know from the mathematics, is we want to equal something from the proportional, then we need a constant. So E is equal to K E V V and L. Now you see here, E we are measuring, K is the constant, B is the known magnetic field, L we know. What is unknown? Velocity. So if I know velocity, then how can we calculate Q? Q is equal to A into, wait Kadam, you are not there that time, so you can understand like this: area meter square, velocity meter per second. So m cube per second means a certain quantity in a time is a flow. That concept you understand. Now the main thing is, if it is not conductive, then story close. You cannot do anything. Clear? So what we discussed? We discussed if EMF can work when fluid is conductive, law is Faraday, how it is a construction, what is its equation, and advantage and disadvantage in a Faraday's law itself. Now two important things. One is the fluid should be conductive, and second thing is very important is this should be always full bore. It should be what? Full bore. Because that L, it cannot be L minus delta L. It should be always L. Because this L is used in this formula. So if my pipeline is not 100% full, then also I cannot use electromagnetic flow meter. That time we have to do some modification in the pipe, so that my pipe is always full of water. There is only two problems, otherwise it's done. Full matlab, like this is my pipe, this is my pipeline. Okay, if my pipeline is like this, the water will be most of the time full, no problem. If my pipeline is like this, so it may happen my flow will be like this. My pipeline is empty. Got it? If my pipeline is like this, it's called an open discharge. Open discharge. Like you can say this open discharge in our bottom tank. So what will happen? Here water may not be full. It is like this. Because here velocity is 0. So it is not full. If I put my flow meter here or here, then it will give a erroneous reading or sometimes 0 reading. So if it is like this, then what we do? We make some arrangement like this, something like this, and we put flow meter over here, so that if there is any water flow, it will go up and down, so this will be always full. Got it? In this type of arrangement, what we do, we will make this type of arrangement. So when water will go up here, so this will be always full. Or in this kind of arrangement, what if it is like this and it is not full, we will make arrangement like this. My pipe, and we put flow meter here. So this portion will be always full of water. That's called a full bore. That's why sometime we use this word. We say, I want a 200 flow meter, then I will write the word like this. Full bore EMF. Full bore 200 flow meter. So that this sentence is always there. So I will always keep in mind that the pipe should be full bore, otherwise it have a difficulty. First flow meter. Okay. Next flow meter. Next we can say ultrasonic. Ultrasonic flow meter. UFM. This ultrasonic flow meter, again a very interesting principle. In this principle, you understand in this way also. I have one pipeline. Okay. In this pipeline, there is a water flow. Water is flowing like this. You know, water flow in a layers. That day we seen. In this type of flow meter, ultrasonic flow meter, whatever ultrasound we do, same ultrasound is used. It have two sensors. One sensor we put here. Other sensor we put here. The putting of this sensor, it also have three different types. But here I am showing you only one type. It may be Z, it may be V, it may be W. But I am showing you right now Z only for the clarity. Now these are the ultrasonic. What it means? It will send an ultrasonic wave here, and this will send ultrasonic wave here. Got it? They are trans receivers. It will also send, it will also send. Now you see one very important thing. The velocity of my fluid is V. And the velocity of ultrasounds in one media is constant. Means if it is an iron, it's a constant. Body, it's a constant. Air, it's constant. Water, it's a constant. It may be different, but it is constant. So let's see, in a water, it is a C. The velocity of ultrasound in the water is C. Okay. Now give attention on this. This sensor is A. This sensor is B. Now when A is sending waves to B, what will happen? What will happen? It will reach early. Why? Because if you see like this angle is theta. So component here is a C cos theta. When it is from this direction, for the A, it is a plus C cos theta. But when B is sending, B is working against the fluid velocity, then that component will be C minus cos theta. Now time. This time reaching from here to here is a TAB. This time from reaching here to here is a TBA. But a very important and interesting thing is the length is same. So we know the formula, V is equal to S by T. Now equation 1, equation 2, L is equal or S is equal. Now S, I am telling S instead of L, I am saying S. S is same, na? This distance is always same. This is the S, or you can say L, whatever. So equation number 1 for the A, equation number A क्या होगी? V plus C cos theta into T है ना, TAB equal to S. For that, V minus C cos theta into TBA equal to S. Equation number 1, equation number 2. When we solve this equation, again we can identify V. Then Q is equal to area into velocity. Now, by the construction, if I talk about the construction of the ultrasonic flow meter, one construction I shown you like this. This is my pipe. Over the pipe, I am putting the two sensors. Okay, this is one. Second is, I have a pipe. One side of the pipe I make a hole. Other side of pipe I am making a hole. And in that hole I am putting one sensor and other sensor. The second. So in the pipe I did. Second I am what? Third what I am doing? Third, in my factory I am making a flow meter. It is having the flange. It is having the pipe. And in factory only I am putting the sensor here and sensor here. And when it is coming to the field, they cut the pipe and in a flange, then nut bolt it tight. So this is the third type of things.